Alright everyone, I thought I'd post a video on distance, rate, and time since we went through those problems so quickly. So this is starting with problem number 5 in your Word Problems Day 2 packet. So the first question, with some of you I know I've already done it, so if you want to skip this one, feel free. But this one says, Mary leaves her house at 2 p.m., traveling at 45 miles per hour. Later, her brother Joe leaves and travels in the same direction at 60 miles per hour. If Joe leaves at 4 p.m., what time will she catch up with Mary? So for my description, I'm just going to write in Mary and Joe. So that's all we're going to put here is we're talking about Mary and we're talking about Joe. And then we're going to fill in what we know about these guys. So now remember, rate is measured in miles per hour, feet per second. So we know that Mary is traveling 45 miles per hour. So we just need to put 45 right there for her rate. And then we know her brother Joe, he's going 60 miles per hour. So I'm just going to put 60 in for Joe. Now, time. Time is not the time of day. We are not going to put 2 p.m. for Mary, and we're not going to put 4 p.m. for Joe. Time is how long they've been traveling, right? So we don't know how long they've been traveling, but we know Mary left at 2 p.m., and we know Joe left after her at 4 p.m. So if I called Mary X, then Joe, if you think about it, even though he left after her, he's been traveling 2 hours less than her, right? She leaves at 2 p.m. She's been traveling for 2 hours, and then Joe leaves at 4 p.m. So he is now going to be X minus 2. Now, you can look at this a different way, and you can call Joe X, and you can call Mary X plus 2. Either way, as long as you understand that Mary is traveling longer than Joe because she left first. So now, distance. The distance column is always rate times time equals distance. So the distance column will always be whatever you put for the rate and the time for your description. So Mary is going to be 45x. So this is the expression that will give you Mary's distance. And Joe is going to be 60. And then in parentheses, he's times x minus 2. Or you could say 60x minus 120. Now, if you think about it, they're going in the same direction, right? So let's just draw a little picture here for a second. Here's Mary. She starts traveling, and her distance is being represented by 45x. And then here's Joe. And Joe's traveling, but he leaves later, but he's still going in the same direction. His distance is being measured as 60 times x minus 2. But by the time they meet, what's going to be true about their distances? Well, their distances are going to be equal, right? They're going in the same direction, even though they left at different times. By the time they meet, their distances will be equal. So that's my equation. My equation is going to be 45x equals 60 times x minus 2. And then we just solve the equation. So when I distribute the 60, I get 45x equals 60x minus 120. Collect your variables to one side, so I subtract 60x. And you get negative 15x equals negative 120. And then when I divide both sides by negative 15, everything ends up becoming positive 8. So then I get x is equal to 8. So now I'm going to go back to my chart that I made here, and I'm going to see, okay, well, what did I say x was? In this particular chart, I said x is Mary's time. So that means that Mary traveled for 8 hours. Now, I'm going to ignore the question right here, and let's just, what if these were all the questions? I'm going to answer every question we possibly could answer. So the first one, how long was Joe driving? Well, Joe was driving for x minus 2. And since x is 8, well, 8 minus 2 is 6. So he was traveling for 6 hours. All right? And now, how long was Mary driving? Well, Mary is x. Mary is 8. So she was driving for 8 hours. Well, how far did Mary drive? Well, to get how far Mary drove, we would just put 8 into her distance. Her distance is represented by 45x, so we would just do 45 times 8. So 45 times 8 is 360. So she traveled 360 miles. Now, how far did Joe drive? Well, we know already that Joe and her drove the same distance, so we already know that that's going to be 360 miles. But I'm going to prove it to you. Joe's distance is being represented with 60 times x minus 2. Well, x minus 2 would be 8 minus 2. 8 minus 2 is 6, and 60 times 6 is 360. Okay? Now the question is, what time did they meet? Well, they're going to meet at the same time. And you can either take the fact that Mary left her house at 2 p.m., right? So Mary left her house at 2 p.m. And how many hours did she travel? Well, she traveled for 8 hours. Well, 2 p.m. plus 8 hours gives me what time? It gives me 10 p.m. So they're going to meet at 10 p.m. Another way you could do it is you could take Joe's time. Joe left at 4 p.m., but he's only traveling for 6 hours. And 4 plus 6 is 10. So now we can actually go back and answer this actual question. What time will he catch up with Mary? That's really the only question I was required to answer, but I wanted to give you all possible questions that you would get. So the answer is 10 p.m. Let's move on to the next one. All right, let's look at the next problem. This is about the Hill family and the Platter family, and they're going on a road trip. It says here that the Hills left 3 hours before the Platters, but the Platters drive an average of 15 miles per hour faster. If it takes the Platter family 13 hours to catch up with the Hill family, how fast are the Hills driving? So let's go ahead and start by writing who we're talking about. We're talking about the Hills, and we're talking about the Platters. All right, and so the first thing mentioned is that the Hills left 3 hours before the Platters. And so now let's read what it says about the Platter family. The Platter family traveled for 13 hours, so their time is 13. And so now if the Hills left before the Platters, well, they've been traveling 3 hours longer than the Platters because they left first. So they will have traveled for 16 hours. So in this problem, we know how long each family is traveling. We don't know their rate. However, it does say the Platters drive an average of 15 miles per hour faster. So we know that the Platters is going to be 15 miles per hour faster than the Hills. So if I call the Hills x, then the Platters have to be x plus 15. You could say if the Platters were x, then the Hills are x minus 15. Either way is going to make the problem work out. So now distance. Distance is always rate times time. So this last column will always be the rate times the time. So Hill's distance is going to be 16x. And the Platter's distance is going to be 13 times x plus 15. And again, this is one where they're going to end up meeting. So by the time they meet with each other, they'll have traveled the same amount of distance. So again, you're going to say 16x equals 13 times x plus 15. And we solve this equation. So distribute the 13 and you get 16x equals 13x plus 13 times 15 is 195. Then we are going to collect our variables to both sides. So subtract 13x from both sides. You get 3x equals 195. And Ben, what's 195 divided by 3? Oh, 65. He's too slow. Oh my gosh, that was fast. Okay, so he gets 65. So I get here that x is equal to 65. Now what the heck does that represent? Well, let's go back up and look at our chart. The x is right here. That's how fast the Hills are going. But let's go back and make sure we're answering the question. So here it says, how fast are the Hills driving? Well, that's easy. The Hills were x. We solved for x. The Hills are driving 65 miles per hour. That's the answer to the question. If I asked any other question, you just use the chart to help you. Like if I said, how fast were the Platters driving? You would just go up here and say, well, Platters, their rate is x plus 15. Since x is 65, you just do 65 plus 15. If I asked for the distance, you just put x in to either one of these and you'd get it. Let's move to the next one. All right, this problem's talking about Jane and Peter. They leave their home traveling in opposite directions on a straight road. Peter drives 15 miles per hour faster than Jane, and after 3 hours, they are 225 miles apart. How many miles did each of them drive? So now we've got Jane and Peter. Descriptions are easy usually. We've got Jane, whoops, and Peter. That does say Jane. Takes the A there. Okay, so now it says Peter drives 15 miles per hour faster than Jane. So we don't actually know their rates, but we know Peter is faster than Jane. So let's say that Jane is x, and let's say that Peter is x plus 15. If you wanted to call Peter X and Jane X minus 15, that would be fine. Then it says after 3 hours, they are 225 miles apart. That means that both of them traveled for 3 hours, right? And they're going in opposite directions this time. They're going in opposite directions. So I'm just going to draw some arrows here saying, okay, they're going in opposite directions. We're going to think about that. And after 3 hours, they're 225 miles apart. That's not the distance of each of them. That's the distance of both of them together, right? So to get each person's distance, Jane's distance is just going to be, remember, rate times time equals distance. This is going to be 3x. And then rate times time for Peter is going to be 3 times x plus 15. And make sure that x plus 15 goes in parentheses, or you just go ahead and distribute it. All right, so now let's just get a picture here. Suppose that this first line I drew right here, this is Jane. Her distance is being represented by 3x. Peter's distance, he's going the different direction. He is going 3x plus 15 miles. So those are their distances. Now, after a certain amount of time, their total distance away from each other is 225 miles. So their combined distance, because they're going in opposite directions, is 225. So in this one, you take their two distances, you add them, and make that equal to 225. So the equation for this one is going to be 3x plus 3 times x plus 15 equals 225. So just be sure that that distance doesn't go in the distance column, right? The distance columns are representing each person's distance, which we don't actually know. So we're going to figure that out. So now let's distribute the 3. So we get 3x plus 45 equals 225. And then we're going to add our like terms. So I get 6x plus 45 equals 225. Then I'm going to subtract 45 from both sides. And I'm going to get 6x equals 180. Then I divide by 6, and I'm going to again get that x is equal to 30. So then we go back up here and we say, okay, well, x is Jane's rate. So Jane was traveling 30 miles per hour. But that's not necessarily the answer to the question. So let's go read the question again. How many miles did each drive? Well, Jane is being represented by 3 times x. So Jane, we just do 3 times 30. And 3 times 30 is 90 miles. And then Peter, we could do 225 minus 90, or we could just plug in the 30 into his expression. So Peter would be 30 right here. 30 plus 15 is 45, and 45 times 3 is 135. So I just plugged it into that expression. And then to double check, you could add those together, and those should equal 225. So there's your answer right there. All right, the next one. Heidi and her sister are out playing in the snow. They are currently 20 miles apart, and they begin to head towards each other at 8 a.m. Heidi is snowmobiling at a rate of 20 miles per hour faster than her sister. Her sister is cross-country skiing at 10 miles per hour. What time did they meet, and how far did each sister travel? So let's start with who we're talking about. We've got Heidi and her sister. Whoops. All right, so they are currently 20 miles apart. This is going to be that's their total distance apart. So we're going to deal with that 20 miles apart later. And they begin to head towards each other. So let's just imagine this for a second. Let's suppose this is Heidi. This is her sister. And they are going towards each other. Okay? Their distance away from each other is 20 miles. So this is going to be another one where I'm adding two distances together to get 20. Okay? All right, so they begin towards each other at 8 a.m. They both leave at 8 a.m., but we don't actually know how long they travel. So the time is not 8. The time is both of these are going to be x because they leave at the same time. Okay? Heidi is snowmobiling at a rate of 20 miles per hour, and her sister is cross-country skiing at 10 miles per hour. So Heidi, her rate is 20, and her sister is 10. And so the times are both x because they both left at 8 a.m. Get your distances for each person by multiplying their rates times their times. So Heidi's going to be 20x, and her sister's going to be 10x. And so the equation is we add their distances together. 20x plus 10x is going to equal
100x.
No, honey, it's a 20 miles.
Oh.
Okay, so now 20 plus 10 is 30x equals 20. And then we divide both sides by 30. Oh no, 30 is not divisible by 20. That's okay, we're allowed to have a fraction. 20 over 30, Ben, what's 20 over 30?
7.
No,
2/3.
2/3. So, it's okay. Can we have 2/3 of an hour? Yes, we can have 2/3 of an hour. Hey, honey, 2/3 of an hour is how many minutes?
40.
40 minutes! Very good. You would just have to do 2/3 of 60 to get that, remember? And 1/3 of 60 is 20, and 20 times 2 is 40. So the answer to the question, well, that's not the answer to the question. It says, what time did they meet? That means they traveled for 40 minutes. And the question is, what time did they meet? Well, what time did they leave? Do you remember what time they left? They left at 8 a.m. So if they left at 8 a.m., 8 a.m. plus 40 minutes is 8:40.
Sure is.
So they met at 8:40. Now the other part of the question is how far did each sister travel? Well, again, remember that x is equal to 2/3 of an hour. So Heidi, her distance is 20 times 2/3. So a reminder, 20 times 2/3. We can't do any cross canceling here, so it would just be 40 over 3. And we don't want to leave it as 40 over 3. We actually want to go ahead and figure out what mixed number that is. So 40 goes into, or 3 goes into 40 13 times, and you have 3 times 13 is 39, so you have 1 left over. So 13 and 1/3 miles, and we know it's miles because they were traveling in miles per hour. So that is Heidi, and I'm just going to put a box around that, and we're going to put these together in just a second, and then I'm going to do 10 times 2/3, so that's 10 over 1 times 2 over 3, so that's equal to 20 over 3, and 20 over 3 is 6 2/3. So, the answer to the question, let me put the answer at the top, okay? So the answer is, at what time did they meet? They met at 8:40, and Heidi traveled 13 1/3 miles. And her sister traveled 6 2/3 miles. So that's the answer to the entire question. All right, let's go on to the last question. Okay, Bill took a trip to see his friend. His friend lives 225 miles away. He drove in town at an average of 30 miles per hour, and he drove on the interstate at an average of 70 miles per hour. So he's going to be driving in town and on the interstate. The trip took 3.5 hours total. How far did Bill drive on the interstate? So in this case, we just have one person, Bill, but we've got two places he's driving. He's driving in town, so that's going to be one of the things. So town. And then the other one's going to be the interstate. And then we also know the rates. The rates in town, he drove 30 miles per hour. And the interstate was 70 miles per hour. Now, the time. This one's a little bit tricky. We haven't had one like this before. So if you think about it, his time in town plus his time in the interstate is a total of 3.5, right? So comparatively, if you think about that, one of them is going to be 3.5 minus x, and the other one's just going to be x. Like if you think about this, like if I just subtract the interstate, however long he traveled on the interstate, if I just subtract that from 3.5, I'm going to get how many hours he traveled in town, right? So one of them is going to be x, and the other one is going to be 3.5 minus x. And it doesn't really matter which one is 3.5 minus x. Just one of them is. Okay? All right, so now I go ahead and I get the distance. The distance in town is going to be measured by 30x, and the distance on the interstate is going to be measured as 70 times 3.5 minus x. Now we know his friend lives 225 miles away, so the total distance that he's going to travel is 225. So this one again is another one where you're going to add, right? So 30x plus 70 times 3.5 minus x, and you can make that 3.5 if you want, is going to equal 225. I'll write that up here and I'll fix that in a minute. All right, so now distribute 70 times 3.5 is going to give me 245. So I'm going to have 30x plus 245 minus 70x equals 225. And so now combine 30 minus 70 is negative 40. So I have negative 40x plus 245 equals 225, and then subtract 245 from 225, and you get negative 20. So I have negative 40x equals negative 20. Divide everything by negative 40, and again, everything becomes positive, but again we have a fraction. So the answer for x is 20 over 40 is 1/2. So they traveled in town, he traveled a half an hour, and on the interstate, he traveled 3.5 minus a half. So he traveled 3 hours, right? So the question is, how far did Bill drive on the interstate? We just take this 1/2 and plug it into that expression right there. So 3.5 minus a half is 3 hours. So the answer to the question is 3 hours. All right, good luck.